Hey all, today we're going to talk about our last type of parallelogram, and those are squares. So a square is a rhombus and a rectangle sort of mixed together. So it has all the same properties as a parallelogram, a rhombus, and a rectangle. So there's nothing really new to add about the sides. It has all the same properties as a parallelogram and a rhombus. Nothing new to add about the angles either. It's going to have all the angles be 90, just like a rectangle. And nothing new to add about the diagonals. It's going to have all the same properties of its diagonals as a rhombus and a rectangle. So they're perpendicular, they bisect the angles, and they're congruent. So the thing about squares is that there's two right triangles here when I draw one diagonal. When I draw the diagonals, these little angles are all 45, so what we end up with are some trig problems. So if I know that the diagonal is 14, and I want to know how big one side is, I can use trig. I can also use special right triangles, and I can even use Pythagorean theorem. In this lesson, I'm going to show you trig and special right triangles. So depending on which of these two 45-degree angles you use, you might use the cosine function or the sine function. So if you use this angle up here, you're going to use cosine. If you're thinking about using this 45-degree angle down here, you could use sine. But either way, when you solve, you get that x is approximately 9.9. If you use special right triangles, if that's something that is easier for you, you could write the proportion 14 over root 2 equals x over 1. Of course, x over 1 simplifies to be x, and in this case, we can just make that a decimal. Since it's possible to use trig, we'll just deal with decimals today. So I'll do one more. Again, I have two 45s once the diagonal is drawn, so I could use either sine or cosine. This is one where x is on the bottom, so I just switch x and cosine, or I switch x and sine. And it doesn't matter, I'll get the same answer. I could use similar right triangles again. X over root 2, 6 over 1, multiply both sides by root 2, and you'll get the same answer. So I did mention before, you could do Pythagorean theorem if you want to. Since this side is 6, that means this other side is 6. So A and B are both 6, C is x. You could solve for x, and you could use Pythagorean theorem. So whichever option you like, you should use. So this is just a little bit of a variation on those two problems, in that I just tell you about the diagonal of a square. So I'm going to draw the square. And if I want to find the length of one side, I'm just going to use the trig option because that's what I like best. So I'm going to use cosine, multiply both sides by 5 root 2, and I can put this straight into my calculator. 5 times root 2 times cosine of 45 gives you 5. This might be one where special right triangles works nicely as well. Again, you could use the Pythagorean theorem, but choose which one is best, which one's easiest, which one you like the most. So pause here and try this one on your own. So again, I'm just going to draw this triangle with a diagonal that's 3, the two 45s there that the diagonal creates by bisecting the angles. I'm looking for the sides, so all these sides are actually x, because in a square they're all the same. I again chose to do trig, and I chose to use cosine. You could have had sine 45 equals x over 3. Either way, you'll get x to be 2.1. Again, you could have used special right triangles here. 3 over root 2 equals x over 1. Or you could have done Pythagorean theorem, x squared plus x squared equals 3 squared. Again, whichever one works for you. So I have one you do for you to do. Make sure you do it. Make sure you submit it on Google, and we'll do some practice in class.